Well, this is Mr. Waddy, and we're talking about Alg2.10.04 homework, probability of disjoint and overlapping events. Hey, you and your friend are among several candidates running for class president. You estimate there is a 45% chance you win, and a 25% chance your friend will win. What is the probability that you or your friend win the election? Now, is it possible that both you and your friend win at the same time? Well, you're running for the same position. You can't both win. And so, no, there's no overlap. So these are disjoint events. Okay? And so in order to calculate the probability, I just have to do probability of A plus the probability of B. And so that, in this scenario, is 0.45. plus 0.25, and I get 0.70, which is 70%, right? And so there's a 70% chance that you or your friend win the election. Wow. Now, based on that, you could end up making some real shady deals that if one of you becomes president, then there's a deal for the other, vice versa. No corruption, no political corruption here. Come on. Problem solving, question 10. Of 162 students honored, oh wow, what a privilege, honored at an academic awards banquet, 48 won awards for the mathematics and 78 won awards for English. There were 14 students who won awards for both, oh lucky dogs, math and English. A newspaper chooses a student at random for an interview. Well, that's a weird way to do a newspaper article, but I guess. What is the probability that the student interviewed won an award for English or math? Wait a minute. So, wait, what? So, like, they would have interviewed a student that didn't win any award? That's weird. Okay. All right. Good for them. Good for them. So, one of the issues here is that there's overlap. There were students who were in both categories. And so, in order to calculate the probability of A or B, well, that's going to be the probability of A, they got a math award, plus the probability of B, that they got the English award. But the problem is, if I add this and that, I've counted these students twice, and that would overestimate the probability. And so I've got to subtract the probability of A and B, count one of those double counts, or subtract one of those double counts, bringing me back to accuracy. All right, and so what do I got? 162 students, 48 won awards in math. So that's 48 out of 162. 78 for English, so add to that, 78 out of 162. And the probability of both was 14. Those were the students who won both awards. And so the probability of A or B, that they got either possible outcome, including both, you just add those and subtract. 48 plus 78 minus 14 happens to be 112 out of 162, which becomes approximately 69%. So 69% chance that they get, that you pick a student at random that had either an English or math award. All right. And that includes the possibility of those 14 kids who had both. All right. Drawing a conclusion. Here we go. I like these ones. These ones are the where you got to rearrange the formula. So this is going to be, let's see, a group of 40 trees in a forest are not growing properly. Oh no, tree beard. A botanist determines that 34 of the trees have a disease or are being damaged by insects. Okay. With 18 trees having a disease and 20 being damaged by insects, what is the probability that a randomly selected tree has both a disease and is being damaged by insects? So the probability of A or B, the fact that there sounds like a both possibility, there's overlap. The trees could be ill and unwell in both regards, rather. And so I've got to do this, probability of A and B, right? Subtract the overlap, essentially. So this time I know that 40 trees in a forest are not... Do I know how many trees total? Did they tell me that? Wait. Oh, they're not all... 40 is the total. All right. A botanist determines 34 have the disease or are being damaged. So 34 out of 40. Oh, man, that's a rough forest. Only 6 are doing okay. Ugh. Then they told 18 have a disease. So 18 out of 40. Probability B, 20 are being damaged by insects. And I don't know how many are in the both category. Those unlucky trees. But using a little bit of algebra, I could solve this. So if I subtract this and this from both sides, I would solve for the negative probability of A and B, and then I just opposite it. So I'm going to do 34, take away 18, take away 20, and opposite it. And that's going to give me probability of A and B equals 4 out of 40. So those are very unlucky trees, which is equal to, by the way, 10%. So 10% of the trees in the forest are being eaten by bugs, and are ill. Too bad. All right, and here's the last problem I'm going to do today. A little bit trickier. A company is focus testing a new fruit drink. All right. What do we know? The focus group is 47% male, so 0.47 right there. Of the responses, 40% of the males and 54% of the females say they would buy the fruit drink. So would buy, 40% of the males and 54% of the females. So slightly different preferences there. What is the probability that a randomly selected person would buy the fruit drink? So it sounds like they didn't interview, or their focus group didn't have equal representation here. They've got 47%. I can find the number of females by subtracting from 1. So that's 53. I can find the number of males that did not buy by subtracting 0.4 from 1. Get 60% of males did not buy. And here, this would be 0.46 that did not buy. Okay? And so I want the probability that a randomly selected person would buy the fruit drink. And so I'm looking at, as far as my tree diagram, this as success and this as success. So what does that mean? Probability that someone buys the fruit drink, that's going to be the probability of A and B, that someone is male and they buy the drink, plus the probability that someone is not male and they buy the drink. Okay, and I'm adding these, and these are disjoint events, right? It wouldn't be both of those things at the same time. So probability of A and B, well, it's going to be kind of multiplying probabilities, and these are dependent events because the males and females had slightly different preferences. So I'm going to do the probability of A, that they're a male, multiplied by the probability that they buy the drink given that they're male. And over here, probability that they're not male, and multiply by the probability that they buy the drink assuming they are not male. Okay? And so now let's fill in these probabilities. So probability of A was 0.47. Probability of buying, given we knew that they were male, was 0.4. Plus probability of not male was 53. Multiplied by the probability that they bought the drink, given that they were not male, was 0.54. Let's multiply these out, and I get clear my memory here, 0.47 times 0.4, 18%. plus 0.53 plus times 0.54. I get 0.286 roughly. Add to that 0.188, and I get approximately 0.4742, which means 47.42% of randomly selected people are buying their drink, according to their focus group. All right, well, thanks for watching, internet friends. Have a good day.